Okay. So yesterday we have started with the revision of first chapter. Then we have done all these database, schema diagram we have done, 3 schema diagram also we have done. Okay. So here we have stopped. Yeah. So this was the thing yesterday we have stopped here. So yesterday we were seeing about database system environment. So what is this database system? The DBMS software together with the data itself, sometimes the applications are also included. That is application program or queries, then DBMS software, stored data or metadata. So then DBM database system, DBMS software, what is user program, application programs or queries, software to process queries or programs, software to access stored data, data definition, metadata, all these we have seen. So today we'll start see what is components of uh, component module of DBMS and their interaction. So you can see here this is a component model of DBMS and their interaction. So we have just seen about there are DDL, DML, DCL, all these. So what is DDL stands for? DDL stands for data definition language statement. So when we want to use that, there is a separate storage, that is what is called, you can see in the down, where uh, uh, this system catalog or data dictionary is available. What is this? The DDL statement. This is a DDL compiler. So again, DBMS, DBA staff. So you can see the privileges. So now, what we can do is database administrator sometimes will be the person who will be giving access, whether should be given the access or should not be given the access. So that's what here the users of DBA are. It can be database user, casual user, application programmer, or parametric user. Or we can see a casual users. It can be interactive query or compiler or query optimizer. Or we may have a application programs, pre-compiler and DML compiler. Or parametric user, we can see host language or a compiled transaction. So then stored the database, that is runtime database process, concurrency control, backup, recovery in subsystems, or store database manager. Then we can see here query and transaction execution, data dictionary or catalog or runtime database processor, store database, concurrency, control, backup, recovery, and store database manager. So that's what you can see here. A component module of DBMS and their interaction. So then overview of database design process. So for any database, these are required, that is specifying a simplified diagram to illustrate the main phases of database design. So in any of the database, we can see a front end and a back end. So what is a front end we are doing? That is functional requirement or functional analysis, high level transaction, high level transaction specification, then DBMS independence, DBMS specific application program design, transaction implementation, then application program. So then back end we can see mini world, requirement collection and analysis or data requirement, conceptual design, conceptual schema in a high level data model, logical design and data model mapping, logical or conceptual schema in a data model of a specific DBMS, then physical design and the internal schema. So this is what the overall design of a database design, that is backend with the front end. How do we interact the backend with the front end tools? So when we have a functional requirement, even the requirement of the database, we have to collect what should be the database, what name should be there, what is the data type. That should also be matching with the front end requirement. So then where we are storing in a physical design or a internal schema. So that's what here overview of database design process. So then let us see one small example, that is a company database. So we need to create a database schema design based on the following requirements for company database. The company is organized into departments. Each department has a name, number, and an employee who manages the department. We keep track of the start date of the department manager. Then department may have several locations. Each department controls a number of projects. Each project has a unique name, unique number, and is located at a single location. That's what here we can see a company database. An example, we need to create a database schema design based on the following requirements of a company database. The company is organized into a department. Each department has a name, number, and an employee who manages the department. We keep track of the start date of the department manager. A department may have several locations. Each department controls a number of projects. Each project has a unique name, unique number, and is located at a single location. That's what here a company database is. So then we store each employee social security number, address, a salary, whether male or a female, or a birth date. Each employee works for one department but may work on several projects. We keep track of number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee. Each employee may have a number of dependents. Each department, for each dependent, we can keep track of their name, whether male or a female, birth date, relationship to the employee. So then how do we draw a year diagram? So the year diagram, you can see employee, department, project, and dependents. So in employee, we can see what are this is entity, and these are all the attributes. So what are the attributes we have? Social security number is one attribute, birth date is another attribute. You can see the social security in this, there is a line there. What it represents is, it's a primary key. So in the same way, you can see the name. Again, name is split into three: first name, middle name, and the last name. So what is this name? This is a composite attribute because again it is further divided. So the name in this case is a composite attribute. And the same way, address of an employee, salary, whether male or a female. So this is a one entity and its attributes. So in the same way, department. So in this department is one entity where name, number, and the location. Name, which department it is, and what is the number of the department. And the location, because it is a multi-valued attribute, so it is in a double oval. Then dependents. In this dependents, we have a name, whether male or a female, birth date, and the relationship with the employee, whether a parent, whether spouse, what is the relationship with the employee. Then because it is not a strong entity, it is a weak entity, so we should have a identity weak this is a dependent is a weak entity, so we have a relationship diagram with the employee. Along with that, supervision. So now in the employee table only, one out of so many employees, one will be elected as a principal, one will be elected as a HOD for a department. The same way here, that's the reason we have a self loop, because there may be supervisors. So now imagine how many principals are there in BMSIT college? One principal. How many HODs are there? Each department, one HOD. That's how here supervision. So then works for. So employee works for department. So works for, you can see whether how many people are working for a department. So now we are around 14 in MCA department. How many of us are working for the MCA department? Employees. In BMSIT, there are a huge number of employees. Out of so many, 14 of us are dedicated for MCA department. That's what works for. And how many hours we work for a day? We work more than 8 hours, 9 hours. That's what here the thing. And the two lines represents it's a total participation. Then the managers, start date, number of employees. Number of employees, again it is a dotted line means derived. Dotted line means derived attribute. So in the same way, works on for which project we are working, whether third semester project, whether fifth semester project, for which project we are working on. So that's the reason employee works on project. Month, how many, M to N. So then hours, how many hours we are working. So then dependents on in the projects, we have a project name, project number, and the location where the project is. Now, suppose if I ask any if the people don't know where is MCA department, then definitely you will say there is a BSN block. In that BSN block, in the second floor, we have a MCA department. That's the same the location. So, what are the attributes? Entities and their attributes are. So, employee entity is one entity. Again, in employee entity, what are the attributes we have? We have attributes of employee entity are name, ID, address, gender, date of birth, and date of joining. Here in this case, which is a primary key? So, the primary key we have taken it as a employee entity. So, and the primary key here we have taken it as a ID. So, like social security number, here we have taken it as a ID. So, in the same way, department entity, attributes of department entity are department number, name, and location. Department number is a primary key for a department entity. That's what a department entity is. Then project entity, attributes of project entity are project number, name, and the location. Then project number is a primary key for a project entity. Then dependent entity, attributes of dependent entity are D number, gender, and the relationship. So what the relationships are? So how do we represent a relationship? Employees works in the department. Yes, definitely. How in BMSIT college, I am working for MCA department. That's what here we can see. Many employees work. Many employees work in one department, but one employee can not work in the many departments. Then manager controls the department. Employee works under a manager of the department, and the manager records the date of joining of the employees in the department. Department has many projects. One department has many projects, but one project can not come under many departments. Employee works on project. One employee works on several projects, and the number of hours worked by the employee on a single project is recorded. Employee has a dependent. Each employee has a dependent. Each dependent is dependent of only one employee. Then, so how do we draw a ER diagram? So what are the main things we want in the ER diagram concept? So main thing we want entity and attributes. So what is the entity? Entity are a specific objects or a thing in the mini world that are represented in the database. For example, the employee, employee is an entity. In that, John Smith is an attribute. The research department is an entity. Again, in that, project X is a entity attribute for a entity called as a project. Okay. Then attributes are properties used to describe an entity. For example, an employee entity may have the attribute name, SSN, social security number, address, male or a female, then birth date. Entity will have a value for each of its attributes. For example, employee entity may have name equals to John Smith, social security number is so much, address equals to some address, male or a female, birth date of a particular employee. Okay, so next we see about types of attributes available. That is simple versus composite. Simple means what? Further we cannot divide. Then that type of attribute we call it as a simple. Then composite, still we can further divide. Then that is called as a composite. Now simple, each entity has a single atomic value for the attribute. For example, SSN or a sex. So here, social security number cannot be further divided. In the same way, male or a female cannot be further divided. Then such type of entities are called as a simple. Then composite, the attributes may be composed of several components or a simple. For example, address. So in address, we have so many subparts. What is apartment number? If it is a house, what is a house number? Which street, city, state, zip code, country, all these comes under the composite attribute. Or name also. So we have just taken a name. So the name can be first name, middle name, and the last name. So the composition may form a hierarchy where some components are themselves composed. So next, continuing with the types of attribute, in general, a composite and multi-valued attributes may be nested arbitrarily to any number of levels, although this is rare. For example, previous degree of a student is a composite multi-valued attribute denoted by previous degree. So we can say college, which college he has studied, which year, what is a degree, what is a field. Then multiple previous degree values can exist. Each has 4 subcomponent attributes, that is college, year, degree, and the field. So we can see here example of a composite attribute, address. So in that address, street, address, city, state, and zip. Hierarchy of composite attribute, number, street, and apartment. Single versus multi-valued. Single valued attributes that can have single value at a particular instance of a time are called single valued attribute. A person cannot have more than one age value. Therefore, age of a person is a single value attribute. Then multi-valued attribute, an attribute having the multiple values. For example, color of a car or previous degree of a student can be a multi-value. So denoted as color or previous degree. Then stored versus derived. So what is a stored versus derived? Stored attribute. Stored attributes are the attributes that pre-exist in the physical database. For example, date of birth, unit price, all these are a stored attribute. Derived attributes are the attributes that do not exist in the physical database, but their values are derived from other attributes present in the database. For example, average salary in a department should not be saved directly in the database. Instead, it can be derived from an employee. For example, age can be derived from a date of birth. So that's how here derived attributes are. Derived attributes are the attributes that do not exist in the physical database, but their values are derived from other attributes present in the database. For example, average salary in the department should not be saved directly in the database. Instead, it can be derived. For example, for another example, age can be derived from the date of birth. Then entity type. Entities with the same basic attributes are grouped or typed into an entity type. For example, the entity type employee or a project. Key attribute, an attribute of an entity type for which each entity must have a unique value is called a key attributes of the entity type. For example, SSN and the employee. So that's how here the key attribute, like your USN number is a key attribute where we can identify just knowing your USN, which college you are, where, which region you are, what is your college code, which year you have joined, which course you have joined, what is your roll number. So all these we can fetch from your USN number. Then we call it as a key attribute. That's a very important key. Using your USN number, we can fetch all your marks cards. Maybe from first to third semester, we can fetch all your marks cards. So then the same way, entity type and a key attributes. A key attribute may be composite. Vehicle tag number is a key of a car entity type with components number, state. An entity type may have more than one key. A car entity type may have 2 keys, vehicle identification number, popularly called VIN, and vehicle tag number, that is number, state, license plate, and the number. Each key is underlined. So when we say it is a primary key, then we represent, to differentiate between the other attributes, each key is underlined. ER diagram, entity type is displayed in a rectangular box. Attributes are displayed as a oval. Each attribute is connected to its entity type. Components of a composite attributes are connected to the oval representing the composite attribute. So that's how here first name we can represent it, name can be represented as first name, middle name and the last name. So then each key attribute is underlined. So we underline when we say it is a key attribute like primary key. So then multi-valued attributes displayed in a double oval. So multi like car color can be more, color can be green, white, whatever it is. Then we represent that as a double oval. So then entity type car with two keys and a corresponding entity type is car. Car is register number, vehicle ID, year, color, make and a model. So then registration number, state and the number, vehicle ID, what is the ID of the vehicle, then the car is a year, model, then color, that is multi-valued attribute, and make. Car, a registration number, comma state, vehicle ID, make, model, year, and the color. The car entity type with two key attributes, registration and vehicle ID, ER diagram, and an entity set with three attributes. So the car 1, ABC 123, Texas. So these are the values what we take for a particular car. The first one is a general one. It is just a format how we take it as a car. What is entity set? Each entity will have a collection of entities stored in the database called the entity set. Three car entity instance in the entity set for car in the previous slide. Same name car is used to refer to both the entity type and the entity set. So entity set is the current state of the entities of that type that are stored in the database. Based on the attributes, we can identify 4 initial entity types in the company database: department, project, employee, dependents. The initial attributes shown are derived from the requirement description. So initial design of an entity type: employee, department, project number. So department, we can see there, initial design of the entity type, department, department name, number, manager, location, manager, start date. And the project, project name, number, location, and controlling department. Then employee, so we have birth date, department name. So in that name, we can take first name, middle name, and last name. Then social security number, sex, salary, address, supervisor, and works on, and the project works on, for which project he is working on, and how many years is they're working for. Then the dependents, relationship, birth date, whether male or a female, employee, and dependent name. So refining the initial design by the introducing relationship, some aspects in the requirement will be represented as relationship. So ER model has 3 main concepts, that is entity, attributes, and the relationship. So what is an entity? Entity and their entity types and an entity set. Attribute, simple, composite, and a multi-value. Relationship and the relationship type and the relationship set. First, we see about relationship and relationship type. So relationship relates two or more distinct entities with a specifying meaning. For example, employee. So employee is an entity, and how it is having a relationship with the other thing. Employee, suppose John Smith is an employee working for a project product X, or employee Franklin Wong manages the research department. So that's how the relationship between is. The relationship of the same type are grouped or typed into a relationship type. For example, the works on relationship type in which employees and projects participates, or the manager's relationship type in which employees and department participates. The degree of relationship type is the number of participating entity types. Both manages and works on are binary relationship. So this is how we can see the relationship instance of the works on, that is N to 1 relationship. So now I am teaching for how many students? I am DBMS lecturer is 1, and for how many students the same DBMS topic is being taught? For 50 students of third semester MCA project relationship is been working, that is N is to 1. So relationship between employee and the department, that is how many employees are there? There may be any number of employees. And working for, so in now if we take an example, in BMSIT college there are so many employees, and how many of them are working for MCA department? There are so many, out of them 14 people are working for MCA department. That's what here, how many employees? E1, E2, E3, like this, so many. Then how many are working for department? D1 is a MCA. So then how many we are there? 14. The same way, how many departments are there in BMSIT college? There are so many departments. So D1 is MCA, D2 is IS, D3 is CS. Like this, we have so many. So then that's how the relationship we can see there. And in the same way, you can see even employee E1 relationship R1, even employee with the relation R1 is working for the department D1. In the same way, how many people are working for D1? So we can see D1, R1 is a relation for E1. Then R6 is a relation with E6. In the same way, R3 is a relationship and the employee is E3. Like this, you can see for department D1, there are 3 employees working. Who are those 3 employees? E1, E3 and E6 are the 3 employees having with the relationship R1, R3 and R6 working for the department D1. So in the same way, D2 is like IS department, where how many employees are there working for D2? Like there are 2 employees right now for this. So R2 and R4 are the 2 employees, are the 2 relationship for the employees E2 and E4 are the 2 employees who are working for the department D2. Similarly, D3 is like CS department. How many employees are there? Here in this diagram, we have R5 and R7. These are the employees who are working and they are E5 and E7. So some instance in the works on relationship set which represents a relationship type works for between employee and the department. So in the same way, here we can see the relationship instance of M is to N works on relationship between employee and the project. Employee, so how many employees are there? There are so many employees, E1, E2, E3, E4, so many. Works on R1, R2, R3, so many works on. And projects, so how many projects we have? We have P4 projects, at least in this diagram. How many people are working for the project P1? There are 2 people who are working. E1 and E2 are the 2 employees who are working for the project P1. The same way for P2, how many employees are working? For P2, there is E3 working. In the same way for P3, how many employees are working? There are E3 and E4 are the 2 employees who are working for project P3. So in the same way, P4, that is E2, E6 are the employees who are working for project P4. In the same way, M is to N relationship works on. So relationship type versus relationship set. So relationship type is a schema description of the relationship, identifies the relationship name and participating entity types, also identifies certain relationship constraints. Relationship set, a current set of relationship instance represents in the database the current state of the relationship type. Each instance in the set relates individual participating entities, one from each participating entity type. In ER diagram, we represent the relationship type as follows. Diamond shaped box is used for displaying a relationship type connected to the participating entity type via a straight line. So now, in a company database schema, by introducing relationship for a company database, 6 relationship types are identified. All are binary relationship. So what do we mean by binary relationship? Where we have a degree of 2. So listed below with their parent participating entity type works for between employees and departments. Managers is also a between employee and departments. So controls between department and project. Then works on between employees and the project. So supervision between employee as a subordinate as well as employee as a supervisor. So then dependents, how many dependents? Between employee and a dependent. That's how we can see the employee thing. So in the same way, ER diagram relationship type or works for n is to 1, manages 1 is to 1, works on m in many to 1, many to many, then controls 1 to n, supervision 1 to n, dependents 1 to n. So here diagrams we can see employee, department, project, dependents. So then employee supervision, that is employee supervision for the employee, that is employee social security number, birth date, name, address, salary, and whether male or a female. Then works on 1 is to n. So because how any number of people can work for the department, and department will be having only one head of the department. So that's how here. The same way, dependents is a weak entity where dependents can be identified by the identity value, that is a dependent of. The same way, the employee, out of so many employees, one will be principal, one will be HOD. That's the reason we have a self loop. So in the same way, controls, the department projects, department have so many projects. So then the same way, department can control the number of projects. In the same way, employees are working for that particular project. That's the reason works on. So I'll stop here and we'll continue this in the next class. Answer your attendance, Asta. Answer your attendance, Asta, Abhinav, Aishwarya.
Present, ma'am.
Amresh. Anu.
Present, ma'am.
Arbaz. Arjun.
Present, ma'am.
Ashok. Benita.
Present, ma'am.
Bhargavi. Bhavishya.
Present, ma'am.
Chaitra.
Present, ma'am.
Devmalai.
Present, ma'am.
Diksha.
Present, ma'am.
Deepika LG. Deepika MB.
Present, ma'am.
Murli Krishna. Kagubai.
Present, ma'am.
Gudia. Harshit.
Present, ma'am.
Junjar. Kavya.
Present, ma'am.
Kishore.
Present, ma'am.
Lata. Manisha. Manjunath. Nayana.
Present, ma'am.
Nilanjan.
Yes, ma'am.
Nishant. Nishant. Pavitra.
Present, ma'am.
Maithili.
Present, ma'am.
Priyanka.
Present, ma'am.
Pavan.
Present, ma'am.
Akash.
Present, ma'am.
Rajeshwari.
Present, ma'am.
Rakesh. Ramya.
Present, ma'am.
Rashmi.
Present, ma'am.
Ravi.
Yes, ma'am.
Vishal.
Rizwan present, ma'am.
Rizwan present. Okay. Savita.
Yes, ma'am.
Shruti.
Ma'am, 13
Yes,
present.
ma'am.
Sneha.
Yes, ma'am.
Spurti. Srinidhi. Srinivas.
Present, ma'am.
Sunil.
Present, ma'am.
Vaishnavi.
Present, ma'am.
Vinny.
Present, ma'am.
Yes, someone was answering.
Ma'am, 13 present.
Ma'am.
Why you people didn't attend? Answer. ಹೇಳಿದಾಗ ಯಾಕೆ ಕೇಳಲಿಲ್ಲ ಅಂಬರೀಶ್. ಎಸ್.
Ma'am, Spurti present.
Mark Spurti. Deepika LG. Yeah, marked.
Ma'am, Vishal present.
Yeah, marked Vishal.
Ma'am, Manisha, ma'am.
Yeah, Manisha marked. Okay, we'll stop.